Sensor Network for Intelligent Predictive Enterprise. SNIPE Sensor Network for Intelligent Predictive Enterprise is a project funded by Trinity Consortium, an Horizon 2020 project aiming to create a network of multidisciplinary and local digital innovation hubs that can contribute to agile production. SNIPE project has created an artificial intelligence-enabled Internet of Things network system for machinery revamping in foundry industries, with the aim to have a real-time monitoring of production processes and enable predictive maintenance on critical phases. SNIPE project has been realized under the coordination of PHY Technology together with Arizzi Fonderie and Chilometro Rosso Innovation District. The three partners are based in the north of Italy, where heavy industry manufacturing companies are predominant. The coordinator of the project, PHY Technology, is the asset provider of the demonstration. It is specialized in the provision of hardware, firmware and software development in electronic and IoT. Arizzi Fonderie is a foundry and casting company which participated as an end user, and it is where the demonstrator has been installed. Chilometro Rosso is one of the leading Italian innovation districts with more than 70 resident partners which represent the industrial landscape of Lombardy region. It performed communication and dissemination activities for the project. The foundry and casting industry, with its predominantly medium-sized structure, is characterized by a low degree of automation due to the very long service life of machines. Machine downtime has to be consequences within the foundry process. The first one is energy waste, which means that energy consumption is not adjustable during the process interruption. The second one is a decrease of productivity level and increase of process instability. Therefore, maintenance is a key area that can drive major cost savings and production value around the world. In this context, SNIPE approach delivered a smart monitoring infrastructure for the revamping of non-digitalized foundry process through the use of a modular and efficient IoT sensor network. SNIPE is based on an artificial intelligence decision support system that collects data such as temperature, engine vibration from the sensor network and then predicts maintenance on specific key processes. The project led the creation of the following tangible outcomes: a sensor network where custom sensor IoT nodes have been designed and implemented, a wearable device based on BLE connectivity to push information to workers through haptic motors, vibration and LED, an IoT gateway with a multi-protocol data gathering device to collect data and transfer to cloud platform with MQTT communication protocol, the development of a cloud dashboard for the visualization of data, their storage and data analysis, an artificial intelligence algorithm that is a custom algorithm to enable prognostic and health management operation with a machine learning model based on the collection of raw data from the field, a cybersecurity E2E suite, which is the implementation of a secure procedure for device certification, private key generation and connection protocol, which secures data exchange. Here you can see pictures of the demonstrator components. SNIPE seeks to achieve the following goals by setting up different key performance indicators: cover at least 3 production processes in the foundry by the smart monitoring infrastructure, reduce by 5% the melting process failure through the monitoring of energy consumption and temperature, prevent at least 20% of conveyor and belt transfer downtime, focusing on engine working condition to improve productivity level, reduce by 8% the molding process failure and bad manufacturing quality by the real-time control of humidity conditions of the green sand. SNIPE Demonstrator focused on the most common layout phases of the foundry and casting industries so to address a whole market segment and present a solution that can contribute to agile manufacturing. The phases interested by SNIPE use case have been the belt conveyor network used to transfer the green sand inside of the plant, melting furnaces, green sand production machines. This approach, based on anomalies detection and prognostic health management, represents an effective improvement against the classic time-based maintenance system, predicting and preventing machine downtime time in manufacturing means to improve production efficiency, reduce energy waste, and increase the competitiveness of European companies. SNIPE use case can be applied to different scenarios. The heavy industry in general, companies facing high-level investments to connect machinery in light of Industry 4.0 challenges, taking into account the revamping versus renewing approach. Industries with an existing network of sensors and devices which could collect data for prognostic and health management algorithms based on artificial intelligence. Every manufacturing company in need of ensuring cybersecurity and prevent cybercrime, energy management and optimization. Thanks to Trinity support, SNIPE use case had the opportunity to be realized and access various support actions. First of all, the monitoring of institutions and companies which facilitated the project implementation. Secondly, the networking opportunity and the participation in relevant events, which gave SNIPE the possibility to be presented in a wider European context. Last but not least, the possibility to share experiences with other demonstrators and learn from each other. For more information, access the Trinity platform through the QR code or contact us at m.lobati@fae.technology. Thank you.